That's how it always works. Now, as some of y'all noticed, the note sheet that I gave you has a lot of stuff on it, yes? This is not as bad as what it looks like, because I wrote it this way because we're going to step through each and every step that we do. Kind of, for those of you who were here, because I know 2 of you weren't here yesterday, how yesterday when we looked at these that were similar to it, how we had a step-by-step-by-step process, this here is that process essentially just written out. Now, the first thing I want you to do is we're going to be filling this in. Because we have 2 main equations. One of them is y equals 1 over 4p, parentheses, x minus h squared plus k. So the first equation that's up there, y equals 1 over 4p, parentheses, x minus h, close parentheses squared plus k. The focus is going to be h, comma, k plus p. The directrix for this here is y equals k minus p. And the axis of symmetry for this here is x is equal to h, and the vertex is h comma k. Our vertex is always going to be h comma k. The other equation is 1 over 4p, y minus k squared plus h. The focus is going to be h plus p, comma k. The directrix is x is equal to h minus p, and the axis of symmetry is y is equal to k. So here, these are our main pieces of information. These are our main 2 equations. Now, the ones that we did yesterday, the vertex was 0, 0. The values for the vertex were 0 and 0. Here, we're going to have a value. We are taking the equations we did yesterday and moving them away from the origin. Its vertex is not going to be on the origin. Now, if you want to use these equations, the ones we did yesterday, where the origin is 0, 0, the vertex is 0, 0, not the origin, where the vertex is 0, 0, it works. It works just fine. Because if you remember yesterday, the focus was 0, comma p, yes? For both, or p, comma 0. Well, if I plug 0 for h and k, well, this would be 0, and 0 plus p is just p. So the equations we had yesterday were these here, just with 0 plugged in for h and k. With 0 plugged in. Yes, they were just a simplified version of what we have here. So the reason we looked at those first was so that you can get an idea and kind of get comfortable with working with them before we start dealing with these here. Now we have these here. Now for the homework assignment we're going to have for this here, you're not going to have to graph. You're not going to have to graph a single thing. You're not even going to have to match a graph. Okay, so now we're going to look at our first equation. So our first example, it's right there on the first page. Y equals 1 over 12, parentheses, x minus 1 squared plus 3. First question, which general equation does this example look like? The first one, because we have x inside the parentheses squared, yes? So circle it. Circle it on that sheet, because that's what we're comparing it to. That's the one we're comparing it to. We're looking and contrasting this to. To our second one, what variables do we have in the general equation? So variables here, we don't include x and y. We have h, we have k, and we have p. We have these 3 variables, yes? Now I'm going to space these out a little bit. H, K, P. Do I know what the value of H is? If I looked at the, so it's X minus 1 inside, right? So the minus and minus match up, so the value of H is 1. So inside the parentheses still comes out the opposite sign. How about K? Do we know the value of K? How about the value of P? Because 1 over 4P kind of matches with 1/12, yes? So we don't know the exact value of P. We might be able to kind of speculate what it could be. So we'll get there in a second. And that is a logical way to do it. And we'll make sure and kind of check it with the math here in a minute. So how do we know the variables go into the parabola's characteristics? Well, the focus is what? For this here, the focus would be our, again, so we're looking at this one here, our first one, the one where y equals, yes? So we can look back at the top. It says the focus for this here is h comma k plus p, yes? So we can fill that in. The vertex is h comma k. The directrix is y equals k minus p. An axis of symmetry is x equals h. Now, as we look at these here, I'm going to get my highlighter. Well, I know this value, and I know this one. But I don't know what p is. We have a good guess. We have an idea. I think we've pretty much found it. We know these two here. I know this one. And I know this one here, yes? Well, just looking at the equation, it gave me everything so far, didn't it? Okay. So hopefully at this point, these notes aren't looking as bad as you thought they were, right? Okay, that's fine. Let's look at number 4. How do the variables match up with the example problem? Well, we showed them right here, didn't we? Because they line up with these here. They line up with our points. So we already did number 5 because we pretty much said how they match up, yes? Because P is going to be the only real exception. So far, because we said H was equal to 1, K is equal to 3, and well, 1 over 4P, I'm going to drop the pen, was equal to our 1/12, yes? I think that's step number 5 or 6, isn't it, the next one? So how do these variables match up? So what do I need to solve for? We need to solve for P, yes? So 1 over 4P is equal to 1/12. 1 over 4P is equal to 1/12 because those match up. Those are in common. Those are alike, yes? So what do we do first? And P. Because the first step is pretty much always going to be the same. We're going to multiply both sides by 4P. Because these two here will cancel out. Which gives us 1 is equal to 4P over 12. 1 is equal to 4P over 12, so we're good with this here. Well, 4 over 12 will reduce, won't it? To P over, last step in solving this would be to do what? Since P is being divided by 3, we do the opposite, which would be multiplication. Because this 3 and this 3 will cancel, giving me P is equal to 3. So now we have the value of P, yes? So our vertex was h comma k. And we said the value of h was? No, it was just 1. And the value of 8, or k, was 3. Now our focus was h comma, so just h was by itself, comma, k plus p. Would be 3 plus, which is? Our directrix is y is equal to k minus p. 3 minus 3 would give us 0. And last but not least, we have the axis of symmetry, which is x is equal to h, which is 1. And we have this here. We have this here. Any questions on any of this here? So this here, as long as we are able to follow kind of these main steps, these aren't that bad, but they can be confusing. So that's why I have it written out like this here. I have it as a step-by-step process out. We're going to look at example number 2. So which example, or which equation does this example problem look like? X equals? So this is similar to x equals 1 over 4p times y minus k squared plus h. Yes? Now this one here, you have to be careful. Because is h still inside the parentheses?
Yeah. Wait, no.
No. Because on the other one, we had y equals. Now we have x equals. So that means it changes this. It changes this here. So it changes the value of h and k. They switch, because now k is inside the parentheses, where on the last one it was outside. So that makes some differences here. So what variables do we have in the general equation? We still have h, k, and p, because those didn't change. But our focus that we're comparing this to is what now? It's h plus p, comma, k. That's a little bit different than the last one. Because when we have y equals, it's what? H, comma, k plus p. Here we have h plus p, comma, k. Now our vertex doesn't really change. It's still h, comma, k. Our directrix is x equals h minus p. And the axis of symmetry is y equals k. So what we should notice on this here is that the variables, or what we're plugging in, where we're plugging in p has changed. It's changed. So again, this is why having these equations, these formulas there and looking at them is helpful, because it can help us keep track of what's going on. Now let's see here, h, k, and p. Or we can say 1 over 4p. So do we know the value of h? It's -5 because h is outside the parentheses this time. H is outside the parentheses. So it's -5. K is now where? Inside. So since we have +2 inside, it comes out as -2. And our 1 over 4p matches with -1/8. Well, in our 4 that we're trying to find, because these are the 4 pieces of information we're trying to identify, yes? Vertex, axis of symmetry, directrix, and vertex. Well, you can do half of the focus because the value of k is -2. So at the very end, I think on the next page of your notes, it has that stuff there. Yes? So for the focus, we can leave the first spot blank, but we can write in the k because it's -2. We can do the whole vertex. Vertex would be -5, -2. Y equals -2. Now I'm going to fill in the h values here. -5, -5, but we don't have everything. We're still missing what? The value of p, yes? Because once we can find the value of p, or once we find the value of p, we will have all the information we need. So what do we need to do? We need to solve for the value of p. Looking at this here, does anybody have a guess at what p is going to be? Almost. -2. But let's work it out. So our first step is going to be to times both sides by 4p, because 4p and 4p cancel out. So what I'm left with is 1 is equal to -4p over 8. It will reduce down to 1 over -p over 2, because 4/8 reduces to 1/2. And then what do we do next? Not just 2, but -2, because we don't want to know the value of -p, we want to know the value of positive p. Because our negative and negative will make a positive and give us -2 for p. Now what we need to do is we need to plug it back in. So I'll leave it there for a second, just for those of you. And we'll plug this back in, and once we plug this back in, we will have all 4 of our points. Because here we're going to have plus -2. Here we're going to have minus -2. Now what's -5 plus -2? So the number that we have here, our focus is -7, -2. Because a negative and negative make a. This leaves us with -3. Question for the ages. But this is our answer. So once we find the value of p, we know the values of h, k, and p, we can plug them back in, and we are done. That's all we have to do for this here. Any questions on any of this here? All right, let's look at example 3. Bless you. Almost. Now, when we look at this here, what is it matching up with? Well, we have y equals, yes? So it's going to match up with our y equals 1 over 4p, parentheses x, minus h squared plus k. Is what we have. So what variables do we use in the general equation? Well, we can just kind of skip, because I feel like at this point we can identify h, k, and 1 over 4p, yes? So looking at this here, what is the value of h? It's -6 because it's coming from inside the parentheses, and since it's positive inside the parentheses, it comes out as negative. The value of k is just going to be 10. And 1 over 4p matches up with 1 over -28. And yes, we can do that, since 1 and 1 on top match up, don't they? So really what we're looking at is what is going to make 4p equal to, well, really -28, yes? So here, 4p equals, so I can both sides by 4, and -28 divided by 4 is what? -7. -7. So the focus for us here, because we had y equals, so the focus is h plus p, comma, k. Well, what is our value of h? Comma, k was? So yes, it would be -13, comma, 10 is our focus. Vertex, comma, 10. We don't have to do anything with that one. Directrix for us was? 10 minus -7. Well, negative and negative make a. So y equals 17. And last but not least, axis of -6 it is. Because x equals.
Sorry.
You're good. Now again, when I say reference these here, do that. There's nothing wrong with looking back at these formulas. Because every time I've been filling this stuff in, I have been referencing back to this. Because it's very easy to get this focus and this focus, or these things here flipped. It's easy to get them flipped. And there's nothing wrong with looking back at them. There's nothing wrong with looking back at them. All right, we're looking at example 4, yes? Hopefully you notice that example 4 looks different than the first 3 we did, yes? Bless you. Now example 4 gave us what? The vertex as 3, 2, and that the focus is 3, 4. Okay. Which general equation does the information match with? This one here, yes? And I would agree. Because if we look at the information given, we have the vertex as 3, 2, yes? So that gives us some information. His vertex is what? In both equations, it's h, comma, k, yes? So it tells me h is 3 and k is 2, yes? It says the focus is 3, 4. Okay. So the 4 in the focus is modified. So if we look at y equals, we have h comma k plus p. The h is not changing, but the y value is. The x value, the spot where x normally is, isn't changing from the vertex, but the y is. And that's what we have, yes? So when I get the focus and vertex, I'm seeing which value is changing. Is the x value changing, or is it the y value? And here we see that the y value changed from 2 to 4. So we're dealing with this one here. If the x value had changed, we'd be dealing with This one here.
So we have to be two pieces.
Exactly. So in the focus, we're saying this value here, 4, is equal to h plus, not h, k plus p, yes? And what did we say k was? So we're saying 4 is equal to 2 plus, so 2 is equal to p. We now have h, k, and p, yes? And we said this matched with y is equal to 1 over 4p times x minus h squared plus k. And we're wanting to find the equation, because if it gives us the vertex and focus, or vertex and directrix, or focus and directrix, if it gives us any two pieces of these three here as the starting point, we're finding the equation. Now, looking at this equation, I'm going to start from the left. So y equals 1 over 4. Well, p is what? X minus h was squared plus, we're almost done. I can't leave 4 times 2 in the denominator. 4 times 2 is? That's it. We're using the focus and vertex to find h, k, and p and plug it in. And I kind of extremely deviated from this. Yes? But I have a feeling at this point y'all are getting this. Yes? So any questions on this here? Now, especially on the test, make sure you have these written down somewhere. Okay? And this is not something I'm trying to undervalue what y'all can do. I need these here to help me. So most likely, if I need it, y'all are probably going to. If you guys have photographic memory and can memorize these, great, do that. But it's sometimes good to have a check to look back on and see, okay? Let's look at the next one. Problem number 5 tells us that the focus is, so we notice that the x value from going from the vertex to the focus changed, yes? If we look at these here, well, for y equals, we have h comma k for the vertex and h comma k plus p for the focus. So when y equals, the y value changes in the focus. When it's x equals h plus p, the x value changes, yes? So that means when we plug this in, we're going to have x equals 1 over 4p times y minus k squared plus h. Value of h. Value of k. Now the focus tells me that 5 is equal to h plus p, yes? What did we say the value of h was? Four is equal to p. 4 is equal to p. Questions on this here? We good with this here? Now all we have to do is what? Plug it in. We have 1 over 4 times our value of p is 4 times y minus our k value is plus 1. Well, 4 times 4 is and that's all we have for this here. that brings us to the last one. Before we start the last one, are there any questions on anything we've done so far today? Any questions on anything we've done so far today? We're good with all this here? Let's look at the last one. The last one we're going to look at. Vertex is -3, -5. The focus is -3, -4.75. I think the y value changed in the focus. Because we went from -5 to -4.75.
Well, you could subtract that.
Huh?
You could subtract that. That's amazing.
So x is going to, or y is going to equal.
And you go like point.
Sorry, I get my.
You're good. 1 over 4p, parenthesis, x minus h squared plus k. So our value of h is what? K is, and we're saying -4.75 is equal to -5 plus p. So we'd add 5 to both sides, and yes, 0.25 is equal to p. 0.25 is equal to p. Any questions on how we found h, k, and p?
I didn't think you could do that. But I guess.
So we're going to plug 0.25 in for p. Our value of h is 3, and k is -5. Now 4 times 0.25. Negative and negative make a. Now we don't leave it as this here, which would equal 1. Do we ever write 1 times anything? No. So we get this here. Any questions on any of this here? Now, if you noticed here, the value of p was 0.25, yes?
Yeah.
Most of what we dealt with, p was like 1/2, because we dealt with 1/2 yesterday. We've dealt with some fractions. We've dealt with the decimal, but most of it today we dealt with whole numbers, yes? Or not x. I'm just going to give you values here. So h, k is equal to -7. P is equal to 2/3. So if we plug this in, and I'm picking one of it, it doesn't matter which, 1 over 4 times 2/3 times x minus h squared, and we'd have -7. And there's a reason I'm showing you this one. 4 times 2/3, would it be 4 times 2? Because we multiply by the numerator, yes? This would be 1 over 8/3 times x minus 2 squared minus 7. We can't leave a fraction in a fraction. The yellow calculators will simplify that. The graphing calculators will do it, because you'd have to do alpha y equals, get a fraction, do 1 over, and do the fraction, and it'll give you a decimal. And in math, so if you have your calculators out, if you hit math, turn it on and hit math. Do you see how the first one says FRAC? That will convert it from a decimal to a fraction. Thank you, Zach. It'll convert it from a decimal to a fraction for you, okay? Because what this works out to be is 3/8. Now, you remember when I kept saying, and we did this yesterday and did it some today, how I kept setting up P as not 4P equals the number? Is because of a case like this here. Is because of a case like this here. Because if I'm trying to solve for this value of P, I have to do the 1 over 4P. I have to do the 1 over 4P because it will not simplify back to 2/3 if I just do 4P equals this. Does that make sense? So this is the case where we have to set 1 over 4P equal to 3/8 to solve for the value of P. This is the case that might come up that we have to set it up this way. Now, if it had been like all the ones we've had before where we have 1 over some number, the way we did it at the end, where we just said 4P equal to that number, it works because 1's on top. But here it doesn't work that way.